Hi everyone, welcome back to another video. So this is a direct follow-on from last week's video when we were doing the John Deere headstock. Right, that's that tacked in there now then. So ready to weld in. Looks like that one has got, it's like 3 runs of weld around it maybe. So I'll do similar on that. I'll do 3 runs around that. But I suppose I best give it some preheat first before I weld it. Just offered that one up to there, and we are about absolutely bang on by the look of it. So that is a little bit higher, but it's because it's bent. If it was straight, then this would be in line with that one. And I did give it a little bit more metal around there, so this one has got slightly more there than what this one has. Make it a bit stronger. There's enough room for it, obviously, because of the grease nipple. If there wasn't any room, the grease nipple wouldn't be able to be there. So yeah, I'm good with that. So yeah, we'll give it a preheat and then get it welded up. Right, so that's that welded in. I did it in 360 degrees, so I started there, went all the way around. You can see on that second weld I sort of started, or I finished too far in, so it's a bit of overlap there, but it's alright. And then same on the other side, 360 degrees all the way around on all 3 welds. Sometimes you can do them neater if you do them half and half, but I think it's an achievement to be able to weld all the way around non-stop. So I like to do it like that. So yeah, just need to wait for that to cool down now. Still pretty hot. Like 100 and... well, it depends where you point it. 190 degrees there. You can see, in last week's video, I sprayed some of the detector spray on the shaft before I welded it up, and someone asked why I was doing that or what I was spraying on it. It's this developer. I learned about it from the comment section actually. Someone said if you spray that on, your infrared heat gun will pick up the heat better because it's not being reflected, which you can see there. I think I've said this before, but I've showed this before. You can see on that top surface there where it's reflective, it's a different colour to where it's not reflective. So that's 190 degrees, and it says that's only 130 degrees. And that's because the steel is reflecting. Not quite sure the full science behind it, but if you spray that developer on it anyway, it reads all the same temperature then. So while that's cooling down, I also have this linkage to sort out as well. So this one you can see that it's bent. This top one's bent, bottom one's alright, and the holes are worn as well. So try and press that straight first, and then I'll probably just hand weld some runs of weld around there, and then put it in the mill and then bar it back to size again. Right, so I tried pressing it, but it sort of just squeezes it together, and well, the other one is not quite straight either, so I don't know whether it's bent that one when I tried straightening that one, or that one was bent anyway. It's slightly better than it was, but I need to hold that end down to that end square and then squash this end down, rather than it trying to bend them both in. Right, that's not really doing anything. That's what I miss about my old bench. This bench is great, but for stuff like this, I could have just done with welding it round one end onto the bench and then either warming it up and braying it. But obviously I'm not going to weld it to this bench. And them clamps are sort of not really designed for what I'm using them for. They're just sort of designed for holding stuff down when you're welding it together, not trying to hammer it straight with a 14-pound sledgehammer. So just somehow I need to hold that end down so it's flat on there, and then push this end down, and that one wants pushing that way as well a little bit. Right, so I've got another plan now. So I'm going to use this thing that I made before when I was pressing them shafts out of that axle pivot. So I'm going to weld this onto there around the back, so that will hold that down flat. I can put that bottle jack, the big bottle jack in there, that 50 tonner, and then jack against that, which will then push down on there and push that down, hopefully. You put a straight edge down there, that is straight until you get to where that chalk mark is, and then it starts lifting up the straight edge. You can see there's a gap under there now, so that's where it needs that's where the bend is. And same if you do it the other way, if you put the straight edge on from that end, it's flat till it gets to there, and then you can see a gap. So if I can get the bottle jack so it's pressing down on that bit, or just after that bit. It seems to be working pretty well, that. So yeah, I've got it welded down there, and then I'm pressing it. I've got a bit of plate underneath the bottle jack, so I'm pressing it just that side of that press mark, which I think you'd have a job doing that in a normal press. And then I've got it closed down to like 80mm there. It's supposed to be, well, it's 90mm at that end. So I'm hoping that'll be enough. So I'll let the pressure off now. See, wasn't quite enough the first time. Right, we're nearly there. It just wants a little bit more. I'll try and get as near as I can. Right, that looks better. Just that one is bent in a bit now, so I need to separate them at this end. I just caught my hand with the grinder. So I'm thinking I could do a welding that down at both ends, and then I have a toe jack, put the toe jack in there and just jack it apart a bit. You can see when I put that straight edge on there, there's a gap at that end now. It's maybe not that critical, but I'd like to get it somewhere near. So I think the way all this lot works is this is sort of in the boom on the front of the machine. That's like a pivot, like a fixed pivot, and I think the ram goes on the top, and then this linkage here goes over that on that side. I think I'm guessing them cutouts have something to do with them cutouts, and then I think that bit, the solid end of that, goes in there, and then they're what hold your boom on, the two pins that hold your boom on, and then yeah, that bit pushes that bit, which then either pulls that or tips it forward. So I think I'm just going to weld this onto here at that end and at that end, and maybe a bit under there, and then put the toe jack in there I just want something just to make this stronger than that, so then when I try and jack it apart at the end, it's going to bend this one and not bend the one I've just straightened. So if I weld it to there, it's just giving it that extra strength for that bit. I haven't really got anything else suitable, so I thought, while I've got this on the bench, I might as well just weld it to that. I think that should do it. I've just remembered I've lent my toe jack to someone, so that's buggered that plan. So the toe jack probably wouldn't have been strong enough anyway, because I think you can only put 5 ton on the toe of it. So I've got the bottle jack in there with a bit of round bar through there and then a flat plate pressing against that. So hopefully that'll do it. Right, there we are, that's better. So, put a straight edge across there. It's sat on both sides of the bush. A little bit of that end has worn away, but the bush hasn't worn away. And it's nice and straight down there now, so I think that'll do for that side. Right, so that is ready to go on the milling machine now. I have just had a bit of a blonde moment. I've realised when I was measuring that one. So when I measured from where the centre of that hole is down to here, I measured it off the straight edge, when what I should have done was just measure it from there to there. So on this one I've got more in there than what I should have. But what I can do to fix that is I can move that hole up a little bit, move them holes up a little bit, and move this hole down a little bit. And then that should gain back what that should lose what I've gained in there. So that's that fastened down onto the mill then. So them slugs that I cut out of the holes I've used as spacers underneath. I don't have any blocks or anything, so I've just used them. I could do with getting some proper like blocks, but at the moment I haven't got any. So yeah, we'll put the edge finder in now, and I'll find that edge. I've squared this up from there down onto the bed, so it should be parallel or near enough parallel with the bed. Yeah, find that edge, go in 60mm or whatever I need for the hole centers, and then I'll find the hole center that way for that one. Then I'll change on to the boring head. I'll bar that one through, and then we'll come down to this one, bar that one through, and then back from there, however many mil I need from there to there, and then bar that one through. Right, I think we should be good for a go then. So I had to use a long bar because it'll need it when I go through there. And I didn't really want to have to change the bar again after doing these two. So I start with a long bar, and I'm using high-speed steel because high-speed steel seems to cut better than the boring bars that I have for it. So I use that. It'll take more out of one side than it will at the other to start with because I've got it 3mm offset. So we'll see how we go at that. Right, should be on the final cut now, to get it out to 69.95 millimeters. So yeah, I'll maybe do a little cut first and then measure it, make sure I'm right before I go all the way through. Right, that's that all done. So made a little bit of mistake on there. I didn't take into account how much deflection the bar had, or the boring head has, whatever. So I was taking quite big cuts out to start with to get it somewhere near, and then I should have done a few smaller passes to get it to final size. I just did one final, well, started going through with one final cut. Obviously the bar had deflected quite a bit, so it was cutting out more than what it should have been. So the top of the hole, it's a good job I stopped to measure it, but the top of the hole is slightly bigger than the rest of the hole, but it was only sort of that much. So the bush fits in when it shouldn't fit in. It wants to be an interference fit. So yeah, I'll have to take that into consideration when I do the rest of them. I should have done anyway, I just didn't for some reason. I don't do enough machining to remember everything that I was supposed to remember. But anyway, we'll move on to that one now. Right, so we're at 69.7mm now, so I'm just going to do some real fine cuts to sneak up on it so I don't overcut it. Right, that's that one done. So I did a few spring passes through that. I should be right on that now. So we move over onto this one. Use the DRO to make sure we're in the right place. Right, so I've done a pass. Well, I've done two passes through there. And just out of interest, that was the swath it was taken out on the first cut. It was quite a big cut, and then without moving the boring head, I did a second cut like a spring pass, and that's what it cut out on the second pass without moving the tool. So it just shows how much deflection there is in that bar. You can see when I've gone back up as well, it's cut on the way back up. The bit of high speed steel I'm using is probably not the sharpest, but it's doing the job anyway. That should be the final cut through here, hopefully. I think I'll make that do. They measure about bang on, and then that one's a bit rough. I can take the high spots off that with a sanding wheel. But yeah, I think I'm good at that. Right, some of that swath was quite big that it was cutting, so I was doing 10 turns of however many thousandths of an inch that is, which works out like 4mm overall. So it was doing 2mm depth of cut, which is quite a lot for a boring head, but it was doing it. I wasn't doing that on the first cut; they were a bit less, but that's why I was getting so much deflection, because I was taking quite a big cut with it. So that's that sorted. I still need to drill the holes in it yet for the grease nipples, but I want to get this milled first while the mill's still set up and it's fresh in my head. I'll get this done. Right, that's better. That pin comes flush with there now. So I've just got them pins sat in there now, and I've just measured from there to that side of the pin to get the hole centres, which is 322. So then now I'm going to just go around there a bit with a die grinder, clean them holes up, and then I'm just going to hand weld round them, and then I'll put it in the mill and then bar it back through to size. Right, so I've got that welded up and I've got it mounted on the mill now. So what I did at this end, well, I cut a bit of 60mm round bar off, drilled it through, and then I fastened that down to the mill bed first, and then sat that over it, and then clamped it down. So I know that that hole is 90 degrees and square to the bed of the mill. So when I bore that one through, I know that that one is going to be square with that one. So now I just need to find the centre of that and the edge finder, and then go 322mm to there. Should be parallel with the bed as well, so I shouldn't have to find the centre that way. It should already be in the centre from that one, and then bar it through back to 60mm. Tacked a bit of plate on the other side. Hopefully that should keep it rigid. I might have to tack another bit on here if it starts chattering or whatever, but it's just, I maybe should have tacked that bit further around. It's just what I had. But anyway, we'll see how that goes. Right, that's that board back out to size. Quite a tight fit. It's the cut quality is not great. I should have re-sharpened that bit of tool steel, I think. But I'll take the high spots off of the sanding wheel, and that should do that. So I'll take that out of there now. Right, that's that link done then. So that's that finished. What I'm going to do now is drill these grease nipple holes in here. So there's one to go there, and then one there, and same at the other side. That one would have been better somewhere else, because it looks like it's cracked across where the grease nipple hole is. Whether it's anything to do with the grease nipple or whether it's just because that is the weakest point. But I'm just going to do it there again because that's where it was when it was standard, sort of how it's designed to be on the machine. So rather than redesign anything, I'm just going to do it how it was. That one should be easy enough to do because I can just sit it on the drilling machine, drill press, and just drill it. Them ones won't sit right that way up, so I might just have to do them by hand. And then we have some new bushes to go in there as well. Just noticed on the old bushes, don't know where they are now, but this hole in the end of here is slightly worn and the bushes were cracked. So even if I did repair that, these ends weren't very good anyway. There's one of the old bushes, you can see it's cracked there because the hole's worn. Right, that's them drilled out for the grease nipples in. I'm not going to put the grease nipples in yet because I'll probably get knocked off when I'm moving it about. So yeah, next job now is to put the bushes in. I don't know whether to use the hollow jack and pull them in, or whether to use the bottle jack and that frame thing I made again and push them in. Maybe use the hollow jack, I think. Right, so I've got all them bushes in, but they're a little bit too tight. So, well, I've already done that one. I've taken that one back out, and then I went round the hole with the sanding wheel and the drill, and then put the bush back in again. And it's a nice fit now, where they're just too tight. I did my holes, what did I do, 69.95, they should have been bang on 70. But I'd rather them be this way than too slack and the bush not be tight in the hole. The interference fit is in the bush, it's not in the hole, so the hole should have been bang on 70, and then they're like 70.1. But yeah, I'll just have to pull that back out again, go around it with the sanding wheel and put it back in. Doesn't take much doing, but it's definitely better than being like that than it is the bush just sliding through the hole. Otherwise it wouldn't be doing any good then. Right, so that's all them. They're all sorted now. I had to take them out again and just clean the holes up a bit. They're all nice now, how they should be. Yes, that's all them sorted. So I'm just going to make some new pins. So I'm going to make a new one of them and 2 new ones of them, and obviously one of them as well. That one's alright, that will go again. That's been a new one not long ago, so that'll go again. I think that's all the pins. And these original pins have been induction hardened, where the ones I'm making will not be induction hardened. So if I can get away with using the original ones, there'll be harder pins than the new ones that I'm making. I'm just going to cut some new flags out, or pin ends, whatever you want to call them. I've got some 10mm over there, I'll cut them out of that. Right, so we've got this pin on fastened down to the bed of the mill now. We're going to mill a slot in it like that for the plate that holds it in. So we've got the cutter set up. It's like a 5.5mm slot drill. Yeah, and then it must be 7mm in and 7mm deep. Right, that's that one in with a bolt. I just want some better bolts, some shorter bolts to go in there. But it's lined up with a slot in that now. So I'm also going to weld a block under there, I think, like I said. And then it's not just relying on the bolts. If the pin tries to turn, it's not going to snap the bolts off. It's got something physical to push against. Now that's them cut out. They just want cleaning up. And then they're to go on there and weld round. And then, oh, that one's actually to go on that one. Just gets welded around there. And these ones actually go over the pin and then get welded round. A bit like that. Right, we're about getting there now. So that's 3 new pins made. That one will go again. That one will go again. That's that link sorted. I welded a block on the bottom of there, like I said I was going to do. I just need some bolts for there. That's that pin made. That's all line bored through. This is all done, so I'm just gonna, well, I've just got it hung up now. I'm just gonna spray that black, and then that's that done. And then, yeah, I think that's about everything. So I'll get the spray gun out and I'll spray that with a spray gun rather than just aerosols. But I'm not going to undercoat it. I'm just going to go straight on with a black semi-gloss. Right, so that is everything sorted. So I've sprayed that as well, the bits where I ground bits off and that. I've given that a spray, pins, and then obviously this bit as well. So yeah, that's that all sorted. So yeah, I'm pretty pleased with that. I mean, it's nothing that complicated, but I'm quite happy that I have the capability to be able to make something like that, from cutting the plate out to machining the bit in the middle to boring the ends out to fit the bushes in. So yeah, them pins won't be as good as the originals. Ideally, they want it to be like EN16 or EN19, and they're only EN8. But providing they're greased enough, they should be all right. But they're considerably cheaper than what they would have been if they were induction hardened like the originals were. And then that is the finished link next to the old link. So it looks like we're near enough on that. So yeah, that's that done. So yeah, that's all for this week. Hope you enjoyed the video. Thanks for watching, and I'll see you next time.